Hey everyone, my name is Harshil. I'm a technical lead here at Velotio, and I have expertise in leading application development for end-to-end product engineering. So the topic I want to be talking about today is modern web. What is modern web? So modern web is basically how modern web applications are actually rendered in the browser. What are the different ways in which they're rendered in the browser? And how to choose one amongst all of these different architectures of rendering these applications for your product's functional requirements that will provide the best experience for your users. Moving on to the different ways that we're going to be talking these different architectures of rendering these applications. So we'll be talking about some age-old ways like server pages. We'll move on to something more modern like client-side rendering or single-page applications. And we'll talk about something more SEO friendly like server-side rendering or static side generation for static stuff, and some really new age, cutting edge offerings for static generation called incremental static regeneration. So moving on to server pages is the most age-old way of actually rendering uh, dynamic content or dynamic web applications in the browser. What this process involved is the browser will request for a page from the server, and these age-old technologies like PHP or JSP will prepare a page on the server itself by talking to the databases, inserting dynamic content, and a nicely structured dynamic page or a nicely structured page with the dynamic content is sent back to the client, which is entered. So this what this meant is that at all the logic of all the business logic, all the session handling was all done on the server side, which meant that every time the user wanted some dynamic content, a new request and the whole process used to happen again, which provided a terrible user experience. It was really slow, and the only place or the only use case that one can think of to use these is if they're forced to use or just to maintain some legacy systems that use these legacy technologies. Moving on to single page applications or client side rendering. So single page applications is when the community realized the potential of what JavaScript did. So what the single page application means is that the entire logic of how the page is rendered, how the interactivity is handled, the inserting of dynamic content in the web pages was all handled by JavaScript. And new age libraries like React, Angular, Vue.js, they all are built on top of these potentials of JavaScript, and they all have their own methods to actually use the potential of JavaScript to create these single page applications. So how this worked is that the browser asked, so there are two types of servers. There's a build server, there's an API server. They could be the same, they could be different. Again, another added advantage. What the build server did is that once the browser requests for so the browser will request for a plain index.html file, and then within that index.html file, the entire JavaScript build, which is responsible for the rendering of the entire application, is actually loaded as a build.js file into the client. Once the build.js file is loaded into the client, it's going to take care of the rendering, the routing, the fetching of data, inserting of dynamic data, and all of that happens through asynchronous JavaScript, which means that JavaScript is able to fetch dynamic content outside of pages through JSONs or XMLs, and then uh, on the fly, a single page entirely is going to make sure that dynamic content is used by JavaScript. So this makes everything super fast. The logic, a lot of business logic can be held on the client side, which makes it really fast. A lot of the session handling is done on the client side, which also makes it really fast. Uh, so in this case, these are a lot of advantages that is provided by SPAs or client-side renderings. What are the disadvantages? Since the index.html file or the initial page file, the page which is actually crawled by Google crawlers or some other search engine optimization crawlers, they don't get a lot of data, since all of the data and the rendering logic is inside a JavaScript file and not an HTML file. The crawlers cannot crawl data, and hence the indexing of the web application is not really good, right? And since there's a lot of asynchronous JavaScript that's happening, which means that there's a lot of data that's fetched on the back end, it involves a lot of spinners that are shown throughout the page. So that just takes some hit on the user experience. So when to use these, when to use single page applications. So if your application is a simple B2B SaaS app where SEO is not needed, where you have a fixed set of users that you want to target, and there'll be a fixed set of traffic that you expect, So that is when a B2B SaaS is really helpful, where functional experience is more important than a general user experience. So some good examples could be admin panels, some internal tooling applications, and some applications which are heavily specified as per user. So before we move on to the other process, we'll talk about hydration. So hydration is basically making your static HTML actually interactive through inserting some JavaScript library into it, like a React or a Vue.js inside it, which will make sure that the rich interactivity that is provided by these new age JavaScript library is actually makes it alive and not just a static HTML into it. Server-side rendering. Server-side rendering is kind of a mix of client-side rendering and server pages. And so what server-side rendering is basically the browser request for a page. The server-side rendering or the SSR server will start building the page on request. It will inject all dynamic content into that page, and it will send the page to the browser. Along with the page, it will also send a build.js file, which can house the entire rendering and interaction logic and the client-side interaction library like React or Vue.js into it. And the client is then hydrated with that build. So it adds the advantage of having a rich interactive page which is ready to view by the user A immediately after the request for the page, and B, it also adds the rich interactivity of a single page application into it. And once the build, or rather the page, is hydrated with these rich interactivity libraries like React or Vue.js, it also makes sure that the experience continues to be really great for the user. So what are some of the disadvantages of SSR is the time to first byte. So there's a whole process involved. The client requests for a page, the server starts creating the page, the server sends the created page to the client, and it also sends another build to actually hydrate that page with the rich interactivity of a client-side library. So this whole process is called time to first byte, the time it takes to actually load the entire page application, which could be a little slow initially. So that is one disadvantage. And since there is some rendering that's happening on the server side and then some interaction that's happening on the client side, so if we don't have the compatibility between the two, it could cause some issues. So when to use these? The good use cases are mostly B2C application where SEO plays a huge part. Since the page that is sent over by the server is rich, it is with content, the crawler can crawl through the content and index the page really well. So B2C apps with high SEO can really play a big part. And at the same time, if the need is also to have a rich functionality or rich functional experience of the page, so that is also supported, since we are hydrating it with some really good libraries like React or Vue.js. And so some good examples could be an e-commerce application where the indexing is really important and the functional experience is also really important. Moving on to something more static site regeneration. What static site regeneration does is that during the build process of your application itself, the server will create the pages that are ready to be served by talking to the database, by talking to some CMS tool and preparing these pages. The server keeps them ready, and once the client requests for it, it's as good as just providing the page that the client has requested for. So once the client requests the pages from the server also responds with the hydration of the build.js file, which means that even the static pages that are served by the server are also rich with interactivity. So what are the disadvantages of using SSG is that dynamic content cannot be served here, because these pages are actually pre-built by the server when the build process of the application is happening. So in case the user wants fresh data or fresh content, they will have to re-request another build of the entire application, and then they can fetch content which is more fresher. So anytime a change is needed, these pre-generated static pages need to be rebuilt during the build process of the application. So when to use these? Mostly static landing pages are a very good example that need rich interactivity and the content is fixed and the SEO needs to be really high. So some good landing pages are a good examples, and some websites that are driven by a headless CMS can also be a good example. Moving on to incremental static regeneration. Incremental static regeneration is really fresh. So the earlier problem with static site generation is that fresh content was not available at the user's disposal. Every time the user wanted a fresh content, they had to re-trigger a build so that the server could create new pages. But in this case, once the client requests for a page, the server will start creating these pages after the first request. They'll start creating these pages which are then again readily available for the client or the browser to request for. And at a threshold time interval, the server will automatically keep regenerating these pages so that every time the user or the client requests for a new page, possibilities are that they might fetch newer content, which means that after a fixed threshold of interval, a new regeneration happens, which means that the user can always get fresh content. What are the disadvantages here? That although there is a threshold after which there is a new regeneration of the static pages with new content happening, there might be a chance that the user is still getting stale data because the regeneration job never happened. Like the regeneration job never happened, which means that uh, the user still might get some stale content. And since there's a regeneration job happening at every threshold or every specified time interval, it could be an expensive process as well. So when to use these? So the one use case that I could think of are job posting websites, the landing pages of job posting website the the SEO is really necessary, since the pages are being served with ready to view content. The crawlers can easily crawl those and they can index the page really well. So that is one use case. And secondly, since job posting websites require fresh data or fresh statistics to be updated for after every time intervals, it's a good use case to consider incremental static regeneration for those cases. So thank you so much for listening to this, and I hope this talk helps you choose a good architecture for your product.